Let us look at theme 4, exponents and logarithms. First thing we are going to look at is an exponent. If we look at this expression, a, we normally say a to the x or a to the power of x, then this is just a short way to write down a times a times a times a x times. So it's a short way to write down that. For example, if we have 3 to the 4, that's the same as 3 times 3 times 3 times 3, which is equal to 9 times 9, which is equal to 81. Incidentally, the 9 times 9 we can write again as 9 squared. So, we can also write minus 3 to the power of 4. Then it means that we have minus 3 times minus 3 times minus 3 times minus 3, which in this case will give us a minus times a minus is a plus, and the minus times a minus is a plus, so we have the answer is plus 81. When we, however, have minus 3 to the 4, then the minus is actually minus 1 times 3 to the 4, so our answer will be minus 81. So when we have an exponent, it only goes with the number directly in front of the exponent. So we need to define first, before we go further. If we look at a to the x, then the a we call the base, the x we call the exponent, and the whole a to the x we call the power. So it's important that we have the correct language when you talk about this. So in the case of a to the x, we just have a short form to write this long multiplication of however many x is in a short way. So let us look at exponents that are integers, and first of all we're going to look at positive exponents. The first law we encounter is the sum rule, and that is actually very easy to understand, because if we take a to the power of m times a to the power of n, what you must know is that the bases must be the same. If the bases are not the same, then the rule does not apply. So if I look at a to the m, then it means that is the same as a times a times a m times. And if I look at a to the n, that gives us a times a times a times a n times. But surely we can write that as a times a times a, and now we have m plus n times the number a multiplied by itself. So that gives us a to the m plus n. So let us look at an example. Suppose we have 4 to the power of 3 times 4 to the power of 2. Then we can write it as 4 times 4 times 4 times 4 times 4, which is equal to 4 times 4 times 4 times 4 times 4, which is the same as 4 to the power of 5, which is exactly the same as 4 to the 3 plus 2. So it's a very simple rule depending on the bases. If the bases are the same, then we can add the exponents. So let us look at the subtraction rules. First of all, consider a to the m divided by a to the n. If we look at the numbers m and n, depending on the size, if we have m larger than n, then it means that we can split up the top part as a to the n times a to the m minus n over a to the n. And then it means, because now from the sum rule we can say n plus m minus n is m. So, and then we can cancel that and we get the rule a to the m minus n. Remember, if we have an equality sign, there, it doesn't matter if we go from the left to the right. We can also go from the right to the left because it's always the same. And in this case, we just considered integers. Remember, the integers are 1, 2, 3, 4, etc. So it is positive whole numbers. If I look at an example, we can have, for instance, 2 to the 4 divided by 2 to the 3. That will give me 2 times 2 times 2 times 2 divided by 2 times 2 times 2. And we know we can divide this. So the answer is 2. We can also write it according to the rule. We can write that as 2 to the 4 minus 3, which is just 2 to the 1, and we don't write the 1, we just write it like that. And whether it is now, the base here is now a positive number or a negative number, the rule will still hold. What happens if m is equal to n? If we look at the rule, we subtract the two numbers if we divide. So if I then have a to the m divided by a to the m, we know we will get, by the rule, we will get a to the m minus m, which is a to the 0. But with regular math, we know that we can divide that, and because we have exactly the same number of a's, top and bottom, all of it will cancel, because at the top we have m times, at the bottom we have m times the a's. So our answer will be exactly 1. So this one and that a to the 0 should give us the same answer. We cannot have two different answers from the same example or from the same problem. So if we now have, for example, 3 to the 2 divided by 3 to the 2, I will get 3 times 3 divided by 3 times 3. That will cancel. I will get the answer of 1, but by the rule, I will have 3 to the power of 2 minus 2, which is 3 to the 0, and that and that is exactly the same. So this gives us our rule a to the 0 equal to 1. But it's very important that you exclude the number of 0. So we will not have that later in first year mathematics. We will see that, just move it up a bit. Later in first year mathematics, we will do limits where we encounter 0 to the 0, and we will see that we do not always get the answer of 1. But for all other a's, we will always get a to the 0 equal to 1. And it simply comes from the subtraction rule, where we have the denominator and the numerator to the same power, the bases to the same power. So we divide and we get the answer of 1.